Okay, so the rule is when an electronegative atom shares electrons with one that is less electronegative than itself, the electrons will spend most of their time circumnavigating the more electronegative atom. Now I've asked you to try drawing some of these using the delta symbol. So let's do the first one, hydrogen fluoride. So you've got a hydrogen atom, this is number one, and it can donate one electron because it has one in its outer shell with the fluorine atom. It's in group 7, so it has 7 in its outer shell. Here we will form a covalent molecule. It's heteroatomic because it's got more than one type of atom. However, fluorine is the most electronegative atom on the periodic table, while hydrogen has almost no electronegativity. It hardly can pull electrons at all. So its electron will spend most of its time orbiting the fluorine and only occasionally going around the hydrogen. So we would say that fluorine has the negative charge, relatively speaking, over the over the hydrogen one. So this end would be positive, this end would be negative. Now my delta signs are pretty lame. You can draw delta much better than me. Take a look at your textbook. But this is the negative end of the molecule, this is the positive end of the molecule. Second one you were asked to draw. We're going to draw hydrogen bromide. Note we've got hydrogen being picked on a lot because that's a classic example of a atom that cannot hold its electrons particularly strongly. 7 in the outer shell for bromine, that's another halogen group 7 atom. Again, bromine is very electronegative compared to hydrogen, so this is going to be the negative end of the molecule, while this is going to be the positive end of the molecule. So you've got positive and negative for hydrogen bromide. The third one I asked you to draw was hydrogen iodide. Hydrogen, iodine, iodine again, group 7, has 7 electrons, shares unevenly with hydrogen. This is the negative end, that's the positive end, relatively speaking. Not as much positivity as a full proton charge because the electrons spend some time up here. Likewise, not as much negativity, that's why we need to put our delta signs in, as an electron, because the electron only spends some time over here. So relatively speaking, it's more negative, and so we have a relative or part charge, partial charge, sum of, that's delta. Half the hydrogen iodide, you had to draw the OH bond. So O, 1, 2, 3, 4, 5, 6, hydrogen. Here it is, we'll put it on this side this time. There's some bonding here. This is the hydroxyl group. Now we won't have fulfilled oxygen, it won't be very happy. Normally what happens to the hydroxyl group is that it will go and cause another species to oxidize, and you'd form the hydroxide ion by getting another electron. But that hasn't happened here. We've got this species here, the hydroxyl. Again, oxygen pulls the electron much more strongly than hydrogen. So we have a partial positive charge versus a partial negative charge. The fifth one you had to draw, we got to NH. Now N, 1, 2, 3, 4, 5, and a hydrogen. Not a particularly happy molecule, this one. We haven't fulfilled any of the outer shells, but let's say we did change it a little bit. We went for NH3, ammonia. Again, we would have this uneven sharing exhibited all around the molecule. Down around the hydrogens, we've got areas of positivity. Up around the nitrogen, area of negativity. And again, this is a polar covalent bond. The sixth one, a sulfur atom and a hydrogen atom. Sulfur, we're going to have 6 in the outer shell. We're going to have 1 for hydrogen. Again, sulfur is far more electronegative. It's closer to fluorine than hydrogen, so it's going to have the negative charge relative to the positive charge. Really got to work on my deltas. The seventh one, you had to draw DG. Oh well, DG stands for Mr. David Grundy, and I suppose if you were talking in this context, you'd have to just draw like a wussy girl who's crying, big tears, because she's lost the tug of war to big tough Hayes dog. So that's how you draw DG.